Hello everyone. This is the implementation of handwritten number recognition project on the FPGA board. So this is the initial training step using ANN Python code. So from here I am generating weights.csv and biases.csv. So this is the file which contains all the weights, and this is the file which contains all the biases generated from my code. So now I'm using this weights and biases to train my FPGA board. So I've used these weights and biases here in the main.c file. So yeah, this is the weights and biases I've used. And so for taking image as an input, this is my input image, and I am using a Python code called imagescan.py, which takes this image as an input and scans it. And from here I am writing all the pixel values of this image into output.csv file, which has all the pixel values. I'm using these pixel values as an input to my neural network. We can observe this here. So this is my HPS part of the code, FPGA part. So now I already have synthesized my code and I'm ready to program my device. So I've connected my device to my system. So I've already set up my output file. So I'll just start this program part. The program of my FPGA is successful, and by default I've set my hex values. I'm using hex 0 here. So my first 7-segment display is set to off by default. So now I have my HPS code ready, and I'll create an executable for this. So my makefile generates a final file named as final itself, which has the executable. I've already loaded the file in my FPGA. So now I have my Linux ready, which is connected to my FPGA. I'll just run my final file. So here I've got an output as predicted digit is 3, and it is also being displayed on the FPGA. So now whenever I want to give any different input image, I think the whole process has to be repeated again. Like the image should be given as an input to imagescan.py, get the pixel values, and use those pixel values in main.c, and just compile the main.c and generate the final file, and dump it in FPGA and run it again on Linux. Thank you.